Hello, my name is Saman Khataei. I'm a PhD candidate at Middle East Technical University, Ankara campus. Today, I'm gonna show you a new method for productivity estimation of construction activities by using 4D BIM. But before diving into the topic, let me give you some explanations about the terminology I'm going to use within this presentation. As you may know, BIM stands for Building Information Modeling. It works as a core that gathers several disciplines, including architectural, structural, mechanical, and electrical engineerings in one place. It goes without saying that, by benefiting from BIM, we can reduce the clashes and reworks. It can be useful for improving the communications among the stakeholders and parties involved in a project. It can increase the quality of works and reliability and accuracy of the initial estimations. Furthermore, by integration of several dimensions into the BIM model, we can come up with various useful analysis. For instance, the integration of time dimension into the BIM model, which is called 4D BIM, we can develop the simulation of workflows of construction that is used for assessing the construction methods and for detection of the clashes among the model elements. Similarly, by integration of cost dimension into the BIM, which is called 5D BIM, we can come up with performing cost analysis. What is productivity? Productivity can be defined as the input to the output or output to one or more inputs in a system. Evidently, it is a key factor determining the performance and success of any business, including the construction business. In general, we use productivity values to determine the activity duration in construction projects. Let's see what has motivated us to develop a method that estimates productivity values. The problem is the productivity values cannot be assumed constant during a construction project. That's because there are several factors affecting the progress of the activities, such as weather and job conditions, material deliveries, the proximity among the elements, and so on. These factors affect the productivity values in a dynamic manner. That's why we tried to deploy a method to consider one of those affecting factors, that is, the proximity of under-execution elements. The outcome of the method is expected to be revised productivity values and subsequently more reliable and accurate schedule plans. Finally, in order to show the capabilities of the method, we implemented on a test project. You can see the flowchart of the method. It consists of several main parts. In the first part, the BIM elements, their posture data, and quantities are extracted using a visual programming tool called Dynamo. After that, a project parameter is created in order to assign unique IDs into the corresponding model elements to be used for matching schedule and BIM model. After that, the system will calculate the distances among the under execution elements, and in the case that these distances exceed the threshold values, the system automatically revise the productivities and reschedule the initial plans accordingly. Let's dive into the details of the mentioned steps. As I mentioned, the productivity values are revised according to the element proximity calculation. This calculation is performed by some coding packages written in Python languages and developed in Dynamo environment. As I mentioned again, in a BIM model, each element can be identified by a unique ID. However, These IDs should be extracted and assigned by using project parameters in order to be useful for the matching processes. What is Dynamo? According to the Autodesk, Dynamo is a visual programming environment that enables designers to explore parametric conceptual designs and automate the tasks. For instance, you see a code package generated in Dynamo environment in order to assign unique IDs into the corresponding BIM elements. In the next step, the model elements posture data, their quantities, and unique IDs are extracted and recorded on a datasheet in Excel tool. This datasheet is used for the generation of an hour-based schedule of works. It should be noted that the initial productivity values, the productivity reduction dates, and the threshold values have to be determined by the user. In addition, the elements posture data and quantities are also used for determining the durations and execution logic in the schedule. In the final step, the system calculates the distances among the under execution elements, and in the case that these distances exceed the threshold values, the system automatically revises the productivity values and reschedule the initial plan. As mentioned, in order to show the capabilities of the method, it is implemented on a test project. Our test project is a two-story steel structure project with approximately 360 square meters gross area. The activities selected are placing and erecting columns and beams. You can see the activities list here, and also the initial productivity values assigned by the user according to his or her engineering judgment. The total duration of the project for execution of the mentioned activities is 87.1 man-hours. The system is run for our test project, and for each working hour, the system checks for the proximity of the under execution elements. In addition, by using some Python scripts, the system will try to find breaching cases in comparison with threshold values. Finally, the results of the run are reported in a datasheet. For instance, in activity A5, which corresponds to level 2 beams, the system has detected two elements breach the threshold values. In addition, the system is capable to report the proximity values. Accordingly, it revises the productivity values and reschedules the initial plan. In our case, the total duration of the project is increased about 12%. That corresponds to almost about 98 hours. That is more realistic and more accurate project duration. To sum up, this research presents a new method and approach for revision of the productivity values. In this method, the activities are presented in an hour-based schedule of works, and for each working hour, a proximity calculation system measures the concurrent element distance by using 4D BIM. As a limitation, the user is supposed to provide threshold values, initial productivity, and productivity reduction rates. The revised productivity values and subsequently a rescheduled plan are the outcomes of our proposed method. And finally, thanks to the more realistic productivity values, more reliable initial estimations can be achieved. That's all for today, and thanks for your kind attention.